2.36. In my version it says an airplane travels 278 meters down a runway before taking off. 276 meters. That would be a distance, a change in distance. So here's my airplane. Oy, that's a bad one. It's trying to take off. I'm going to lay down some coordinates. I'm going to call this the x-axis. Everything in that direction is positive. Everything in this direction is negative. And this position is 0. So this is my reference point. So if this is the initial position, it starts at rest, it said. So its initial velocity is 0. And it becomes airborne in 8 seconds. So that from initial to the final position, the change in time, the corresponding change in time is 8 seconds. How fast is it moving at takeoff? Here's the question. How fast the final velocity? I don't know. That's what we're going to try to find out. Now this is, let's see, it says it has constant acceleration. We don't know what it is. It's a constant though. So if we want to know the final velocity, we can look at our kinematic equations and use the ones where there's a constant velocity. Final velocity is equal to your initial velocity plus your acceleration in time. This one looks good. This is what we want to know. But unfortunately it has acceleration in it, which is not going to help us because we don't know the acceleration. So if we don't know this acceleration, we can't calculate this final velocity, at least not with just one equation. There's another equation with velocity. Final velocity squared. How fast you end up going is a function of how fast you start, plus over what distance you accelerate. Again, acceleration's in there, so we can't use this equation to directly calculate for the final velocity. It seems that our acceleration, we're not going to be able to calculate the final velocity unless we calculate the acceleration. So this is an example of a problem where to find the answer, you're going to have to calculate something intermediate. You're not going to be able to jump directly to the answer in one equation. So really our task now, we've recognized, is we need to find the acceleration before we can find the final velocity. So, another equation, and what we have to work with are positions, which we know. We know the final position. We know the initial position, and we know time. So there's one other kinematic equation for constant acceleration. So, this kinematic equation says where you end up, the final position you end up at is a function of your initial position plus your initial velocity over some time plus your acceleration over time squared. Our initial position is 0. Our initial velocity is 0 because we start at the end of the runway at rest, and we called the end of the runway 0. We don't know acceleration, but we do know the final position, and we know the time. So from this equation, we can solve for acceleration. I can multiply both sides by 2, divide both sides by delta t squared, and have an equation for A. Both sides multiplied by 2, both sides divided by delta t squared. We can have a value for A. Calculate A, and then substitute it into one of these equations to calculate a final velocity. It looks like this equation is the easiest one. So to wrap up, a kinematic problem, one dimension, constant acceleration. We want to know the final velocity. We can't go straight to the final velocity with one equation because we don't know the acceleration. Back up, say, okay, the real problem, the first problem to solve this is we need acceleration. So make that your focus, solve for acceleration first. Whatever answer you calculate for acceleration, use in some other equation to help you calculate the final velocity.